Welcome Year 7. This is SLG, Solids, Liquids and Gases, Lesson 7. Where has all the liquid acetone gone? Well, we were going to use some acetone, but you don't have to do this. What you could do is as follows. Just try this. You take the back of your hand, put it into a clench, lick it, and after you've licked it with your tongue, blow over it. Think about what happens to the liquid and what your hand feels like. Well, that's the first question there. What happens to the liquid? It actually, some of the liquid starts to evaporate. And what does your hand feel like? It feels cooler. So, let's complete this paragraph here. When a... Oh, I don't think we've got all the... words here. When a liquid, can't see that, but when a liquid turns into a gas below its boiling point, we call that evaporation. The liquid particles need heat energy to escape from the surface of the liquid, and then they turn into a gas. Where do they get this heat energy from? They take this energy from whatever surface they are on. In other words, from your hand. And this causes your hand to cool down. It's the same with sweating as well. Sweating, you produce a liquid on the surface of your skin. The sweat, the liquid, then takes heat energy from your skin. It evaporates, and that causes your skin to cool down. Now, you can have a go at homework 2 on your own. Write it into your books. That's question 1 from homework 2. And there's question 2 from homework 2. You give it a go. It's out of 7 marks. We'll mark this on your return. Expansion and contraction. Expanding and contracting. You can see in the middle a balloon. If it contracts, it gets smaller. If the balloon, if you blow air into it, it expands, it gets larger. So contraction means getting smaller, expansion means getting bigger. We're going to do a couple of experiments involving a ball and the ring and a bar and a gauge. You're going to see a video on it, and then you are going to provide an explanation. What explanation can you provide for these last experiments?
Now looking at expansion and contraction. You've got a page in your book that says expand and contract, and we've got the ball and ring. Now what I've got here is a metal rod with a ball on the end and a metal rod with a ring on the end. And at the moment, before heating, the ball fits through the ring. What I'm now going to do, and you can see the Bunsen in front of me, roaring flame, I'm going to hold the ball into the Bunsen flame. And what should happen is the ball will heat up, and as it heats up, something should happen to it. We're going to try the ball in the ring again once it's hot. Now the ball doesn't fit through the ring. I'm going to try something similar with, I'll come back to the ball and ring in a minute. I'm going to try something similar with a bar and gauge. I've got a bar here and a gauge there. You've got a hole at the top of the gauge. Now at the moment the bar just fits in the gauge there and can slot through the hole there. I'm going to heat the bar in the Bunsen. Now if you think about the particles in a solid, they're packed very closely together, no room to move, but what will happen when you heat the solid is that they will vibrate. They won't move out of position, so you can see me rocking back and forth now. That's what the particles will do. As they do that, as they vibrate, the solid expands. And after a few minutes heating there, I can't fit the gauge into, I can't fit the bar into the gauge. And it just doesn't quite fit through the hole there. Okay, now this has been cooling down for a couple of minutes, the ball and the ring. Now the ball will just about fit through the ring. Give it a couple more minutes and it will fit all the way through. So if we cool it down into some water, it should, yeah, it fits through again. So this expansion and contraction is a reversible process. When it gets hot, it's heated up and it expands. When it cools, it contracts. And again, for the bar and gauge, I might not have quite enough time of cooling here, but the bar will fit back into the gauge once it's cool.
Right, so you've seen the video. What explanation can you provide for the last experiments? It's all to do with hot objects expand and cooler objects contract. Problems with expansion. You can see bottom right hand corner, look what happens to railway lines if they're laid incorrectly in hot weather. They expand and no train can travel along there. How do they get round it? Well, look at this top left hand picture. They leave a tiny little gap, an expansion gap between railway lines. And of course, that is when you get that type of noise coming from the train as the train wheels move over and hit that small gap. That is there to allow the metal to expand and contract, but still keep its shape. Applying what you know. You can have a go at this. You put the red words into the correct gaps. And can you think of any other expansion or contraction events that occur during heating or cooling? Maybe you can write them down. Have a go at this. This is homework 3. You have a go at this. It's out of 7 marks. It's true or false. Out of 15 marks altogether. And now expanding gases. Let's have a look at another video.
Next we're looking at expanding gases. In this round bottom flask is filled with air. We've got a glass tube going all the way through a cork at the bottom into coloured liquid at the bottom. And what I'm going to do is I'm going to heat up the gas in this round bottom flask. And I'm going to use a hairdryer. So what's going to happen is the gas in the round bottom flask is going to expand. Now at the bottom you should be able to see bubbles. If you look really closely, there's bubbling at the bottom here because the gas has to have somewhere to go. It's expanding, it needs more space, so the only place it can go is out through the tube into the liquid. So after 5 minutes you can see that there's no more bubbles coming out of the tube. We're going to knock the hairdryer off and we're going to allow this to cool. Now as the remaining air in this round bottom flask cools, it will contract. And let's see what happens.
We're on again.
So you can see now that the level of liquid is moving up the glass tube from the beaker. So where the air has been pushed out, now because the air is contracting back into the round bottom flask, what air is left there, it's sucking up the water as it's contracting, and you can see the level of water is here.
Fantastic little experiment. I'm going to complete the sentences now. You just put in the red words. When the air in the flask is warmed, it expands and air bubbles flow out from the end of the tube. You saw that. You saw the bubbles coming out at the start. However, you remove the hairdryer and the following happens. When the flask cools down again, the air inside contracts, and so water rises up the tube. You saw that as well. Final experiment, expanding gases. Watch the demonstration. Apologies, expanding liquids. Watch the vid.
So now we're looking at expanding liquids. In this big beaker I've got a conical flask. In the conical flask I've got coloured liquid, and the liquid is in the glass tube here and it's coming up to this height that I've marked here. I've got a recently boiled kettle. If I pour the boiling water into the beaker, you should be able to see my original mark. My original mark is there, and now you can see that the level of liquid has risen up, and as it cools down then the opposite will happen. But you can see, because of the heat from this water, that the liquid inside the conical flask is expanding.
Great. Thank you very much, Miss Lees and Mr. Hancock, for these videos. Let's just fill in the missing words here. Expanding liquids. When the water gets hot, it expands and it moves up the tube. When it cools, it's going to do the opposite. When it cools, it drops and moves, when it cools, it contracts and moves down the tube. Now, have a think. I'm not going to give you the answer to this. What piece of lab equipment that we have uses this principle of expansion and contraction? I wonder. And finally, a homework 4, particle theory questions. Question 1 is out of 7 marks there. Have a go at that. And, it's a test in our next lesson. So that is the end of the SLG booklet. See you soon, Year 7.